This presentation was originally given at the Internet Research 10 conference as part of a panel on video game communities. The Xbox is a video game console created by Microsoft in 2002 and discontinued in 2006. Out of the box, it can play licensed games developed specifically for the Xbox and play music files ripped into its hard drive. With hardware extensions, those licensed by Microsoft, users could officially play DVDs, connect to Microsoft's proprietary gaming network, Xbox Live, and load saved game states through a USB adapter. All of these extended capabilities require purchasing extra material from Microsoft itself or licensed third-party developers. XBMC was formerly known as Xbox Media Center, but now the acronym has been changed to the semi-recursive XBMC Media Center to separate itself, mostly in a legal capacity, from Microsoft. Officially, it can be installed in Windows, Mac, and Linux operating systems, but it is commonly installed on the Xbox hardware, although this process breaks legal agreements that Team XBMC are under. Simply compiling software unauthorized by Microsoft developed to be run on the Xbox is considered a crime by many. This is what it looks like when it's running on any system. As is typical in Media Center applications, it provides organizational structure, or a library like iTunes does, for media files stored in any number of locations. You can see the navigation to scripts where users can install plugin functionality that they create or have been shared. The most common example is a script that allows the user to search and view YouTube videos through XBMC. This is a chart created by Nick Monfort and Ian Bagost in their book Racing the Beam about the Atari VCS. Though I'm dealing with the gaming platform as well, this organization is typical of all digital media. What I'm focusing on is a trend bridging access and programmability within code to abstracted hacking processes that deal solely within the interface and functionality of software. Code is what is written in a programming language that directly informs the form and function of software. In turn, code is determined by the platform, which in this case is proprietary Xbox software development environment combined with its hardware. As we go up this chart, the software is more and more abstracted from its physical implementation. Wendy Chun says that although the term program as both noun and verb predates the modern digital computer, programmability and programmable do not. It is through this characteristic of programmability that software is a uniquely cultural technology. Humans typically encounter digital technology through the mediation of software, which is significantly untethered from the physical states of discrete computing machinery. This mediation is one of what computer science refers to as abstraction. The introductory programming textbook, How to Think Like a Computer Scientist, defines abstraction as generalization by reducing the information content of a concept, abstracting out the details, and making the program easier to understand. This process has come about at all levels of code, between binary circuitry and assembly language representation, to object-oriented programming, and the representational end-user graphical user interface. This domain of software code is constructed culturally over time, and its implementation is programmable at a number of levels. The platform deals directly with electronic devices and microprocessors, typically to the binary code and machine language that runs on top of it. When you're dealing with code, the programming language that any code is written in depends upon that platform, but also creates abstractions for simplifying the development and use of software. As we go up, the form and function of software is abstracted from the code, and the interface is often abstracted to a degree that makes understanding the underlying platform and code nearly impossible. There's a drastic shift between altering the code of a given software and manipulating it through its interface. So as it becomes easier to use, typically programmability decreases. Programmability is theoretically wider with access to lower levels of programming. Programmability is a property of digital technologies that I have borrowed from Wendy Chun. As you might guess from the syntax of the word itself, it is a machine's capability of being programmed. This means when you're looking at a device and you have access to the binary data that runs it, you can edit that data and it will perform computation that any binary data processor can perform. Friedrich Kittler talks about the microprocessor as a near-perfect Turing machine for this reason. Modifying code directly often involves requisite knowledge of a specific programming language and an ability to comprehend procedural mathematics in the form of a complex algebra and calculus. There are cultural and technical restrictions that limit programmability on all levels, but the most relevant to discussion of variation in abstraction as we go up and down the chart is invisibility. As code becomes abstracted, the specifics of its functions are masked. For example, a graphical interface limits your ability to perceive the computational processes taking place in an action, like moving a file from one directory to another or sending an email. These are incredibly complex tasks when you think of them in zeros and ones, but when you actually click your mouse and type on a keyboard, the abstraction is what makes it so usable. And perhaps the most important claim from this argument, if you cannot study a particular coding environment on a lower level, such as the Microsoft video game platform, you cannot possess the required knowledge about that system in order to program it. Therefore, programmability is suppressed, and the authorized use of that system is what one can only perform. Going back to the chart of levels from earlier, I've introduced some of the variables I've discussed. As you can see, moving from concrete electronics through binary code, through high-level programming languages, through all the way to the user's cognition, the data and function becomes more and more abstract. This means it becomes simpler to use, but the user has restricted access and functionality within the scope of its use. I'm not going to tell you within the scope of this project how to hack an Xbox, but you can just Google it. In fact, Googling, in quotes, XBMC Xbox install will provide thoroughly simplified operations that require little other knowledge but that which the typical computer user is already familiar with. Running programs, decompressing zip files, it's quite simple. And that's what's important about this. If we consider what level of programming skill, comprehension, and access was previously required to hack a complicated gaming platform before the advent of XBMC software, you'd find yourself dealing with command line interfaces, FTP protocol manipulation, etc. Even hardware modification to the Xbox circuitry. That's not something the casual user would want to deal with. What happens now, though, is that a specialized group, the developer community behind XBMC's Xbox implementation, develops code which is further abstracted to the level of graphical interface, allowing the process of hacking to be removed from the act of hacking. So, programmability is required initially for the hacker, but subsequent users of that hack may rely only on the software to access those levels. The lower levels of programming and higher levels of programmability may remain invisible to that user, allowing low-level modification to be simple and abstract. In other words, a trend toward abstraction in all computation is exhibited here in the installation of XBMC by making unauthorized access a function of software rather than the user or hacker.